For the longest time, our relationship with AI has been pretty simple, right? We ask a question, it gives an answer. But we are right on the edge of a huge shift. We're moving from just chatting with AI to actually working with it. And that, my friends, requires a completely different way of thinking, a whole new architecture.
So, let's get right into it. The main idea we're going to unpack here is this big jump from a simple AI chat partner to a genuinely capable digital worker. And believe me, it is a much bigger leap than it sounds.
And this really breaks down that difference. On one side, you've got the classic chatbot. It's passive. It just sits there waiting for you, great for simple Q&A. But on the other side, that's the future. That's an active collaborator, something that can handle complex, multi-step jobs and actually complete real work.
But here's the problem. If you just take a really powerful AI model and throw a task at it, it's completely lost. The source material for this put it perfectly. Without a proper structure, an agent is like a ship without a lighthouse, just wandering around blindly. It needs an architecture.
So how do you build that lighthouse? Well, the solution is a 5-layer blueprint. It's a clear architectural plan that takes a simple model and transforms it into a powerful, effective agent. This is the system that gives it purpose and direction.
And here they are, the 5 layers we're gonna build, right from the ground up. We'll start with the foundation, the model. Then we give it a brain, add some context, a pair of hands, and finally, the team that it works with. So let's get to it.
All right, let's start the construction. We're going to begin with what you could call the agent's internal cognitive stack. These are the first few layers that allow it to actually think, plan, and crucially remember. At the very bottom, you've got the foundation, the large language model itself. The easiest way to think about this is as the engine. It's the core component that provides all the raw horsepower for everything else we're about to build on top.
But here's the thing. Choosing an engine always involves trade-offs. What do you need most? Do you need incredible reasoning power for complex analysis? Or do you need raw speed for real-time interaction? Maybe you need the control and transparency you get from open-weight models. There's no single best engine. It all depends on the job at hand.
Now here's where you see the next big leap. A traditional chatbot is basically just input, then output. It's a one-step process. But an AI agent? Oh, its process is so much more sophisticated. It has to reason about a problem, reflect on it, create a plan, and only then does it actually act.
And that whole process, that's the job of the reasoning layer. This is the brain of the operation. Without it, even the most powerful model in the world just kind of collapses into randomness when it faces a complex task. This layer is what provides the actual intelligence.
But even the smartest brain has a critical, fundamental limitation right out of the box. It's a challenge so core to how these things work, we're going to call it the goldfish problem.
And here's what we mean by that. By default, language models have almost zero memory. They forget instructions, they lose track of the main objective, and they drift way off course during long tasks. This makes them incredibly unreliable for any kind of serious work.
So, how do we solve the goldfish problem? We add a dedicated memory layer, and this one addition completely transforms an agent from a forgetful little toy into a reliable tool. All of a sudden, it can retain its main objectives, recall your past conversations, and even work on a project across multiple sessions. Memory is basically the agent's operating system.
Okay, so our agent can think and it can remember. That's a huge step, but it's not enough. I mean, a mind without a body can't really get anything done, can it? So in this next phase, it's time to give our agent some hands.
This quote from the source material is the perfect way to think about it. You can have the most brilliant reasoning skills and a perfect memory, but if you can't actually interact with the world, you're pretty much useless. An agent needs to be able to do things.
And that is the entire purpose of the tools layer. This is what gives our smart, remembering agent its hands. It's what allows it to perform actions and manipulate its environment. It's what turns it from just a thinker into a doer.
So what kind of actions are we talking about here? Well, tools can be anything from making an API call to another service, to browsing the web for up-to-the-minute information, to querying a database, or even executing a piece of code. This is how the agent gets its work done in the real digital world.
Now we're at the top of our stack, the final and maybe most misunderstood layer. See, the goal isn't to build one single giant know-it-all agent. That just doesn't scale. Instead, the most effective systems use an orchestration layer to create a whole team of specialized agents.
Think of it like a company.
You don't hire one person to do everything. You hire specialists. It's the same idea. You have specialized sub-agents that have very specific roles, you have coordinators that manage the workflow like a project manager, and you can even have swarms of agents that tackle tasks in parallel. This is how you achieve real scale and complexity.
So when you put all 5 of these layers together, you start to see that building effective agents isn't about writing the perfect prompt anymore. It's about being an architect. And this brings us to the biggest challenge that's facing all of those architects today.
With all of these moving parts, the model, the reasoning, the tools, the orchestration, what is the single biggest bottleneck? What's the one thing holding back progress more than anything else?
It all comes back to memory. Building reliable, long-term, and consistent memory is by far the hardest part of building advanced agents right now.
And it's a difficult engineering problem for a reason. It's not just about saving information. It's about intelligently deciding what to forget, figuring out what's most relevant, guaranteeing everything stays consistent over time, and blending all different kinds of data storage. It is a massive, massive challenge.
So, as we wrap this up, I want to leave you with a final question to think about. Whether you're building these systems or just getting ready to use them, which one of these 5 layers, the model, the reasoning, the memory, the tools, or the orchestration, presents the biggest challenge or maybe the biggest opportunity for you? Because that, right there, is the central question for every AI architect today.